Right now, I'm 3D printing the parts for this amazing display cabinet, built with a huge variety of materials. The creativity and engineering in this project are beyond what I can explain briefly, so watch till the end to witness the whole process of this creation. This project has over 900 parts in total, with few hundreds being 3D printed. Every single one was designed for practical purposes, creating a revolutionary swing door system you won't find anywhere else in the world. And this project is for our family friend Jane, who's very popular on Instagram. This display cabinet will go into her home, alongside other projects I'm also creating for her. It took a few days to completely print all the parts before bringing everything to the workshop to assemble. This is a large structure, and I will prefer to do the assembly on my super reliable MFT centerpiece assembly table. Over here, I'm punching out the prepared holes to exact dimensions. Every part needs processing before assembly. For example, we must tap the extrusion ends before inserting screws, and use precision jigs to drill holes at exact positions for the aluminum frame. Therefore, what we need is our 2020 drill guide system. It uses a long extrusion to position drill guides at precise intervals for repeated, accurate drilling. Here's how we mount the drill guides onto the extrusion. First, we slide multiple drill guides on, position them exactly using the tape ruler, and tighten the knobs to lock them in place. I've used this drill guide system for years now. It eliminates positioning jigs one by one for repeat tasks, saving a serious amount of time. Before continuing, I'll drill some holes 10 mm from the edge of the extrusion first. This jig handles it accurately and quickly, with no marked lines needed. Working on this assembly table is such a blessing. Its clamping options are limitless, and the sheer weight of the assembly table delivers security. For large projects, that sturdiness alone is a safety essential boost. Want to watch how this assembly table is built? Well then, you'll need to subscribe. Once the video's done, you'll be notified. Drilling with these jigs has been a pleasure. Setup takes only moments. No measurements needed, just 2 clamps, no bulky drill press. The accuracy is impeccable and reliable, speeding up the project dramatically. And after chamfering the hole, this is the perfect result we get. By repeating the same steps with the jig on the adjacent face, this extrusion is ready for assembly. If you want to build a beautiful display cabinet at home, head to our website and download these plans. The project might be complex, but the final satisfaction is incredibly rewarding. Now, let's return to our drill guide system. We'll make repeated drills on the longest extrusions of this structure. A few more clamps will hold everything in place, and the drilling can begin. This system guarantees identical hole placements every time. We will eliminate tedious measuring and multiple jig setups. Every hole comes out perfect due to the initial positioning of the drill guides. The 80-20 rule is clearly applied here, where most work happens up front. By flipping the workpiece, we can repeat the same hole pattern on the adjacent side. Even for me, I still need to refer to my drawing diagrams. These designs were finalized months before assembly, and just like you, I have to follow the plans strictly, using the notes provided in the download to create the masterpiece. Here, you can see we're also drilling a 2040 extrusion with this system. Its applications for your projects are endless, limited only by your creativity. But of course, different tasks require different tools. And in this workshop, we've created custom jigs for every job. And in this instance, we'll need to make a hole in this corner, neatly and precisely, 10 mm from the sides. This offset jig will help us do that, literally within 1 minute. The extrusion sides will also need drilling. For this, I did prepared measurements to align the jig. Using this freehand drilling jig, we made multiple precise holes in record time. There's more drilling to be done, but we'll tackle it as we progress deeper into the project. And with these last 2 holes, we're capping off the material preparation and begin the assembly process. All the groundwork we did earlier laid the foundation for us to put the frame together. With every hole precisely placed, we can now easily access screw heads within the extrusions. These profiles will form the display cabinet's front face. We'll check each extrusion's measurements twice, use flush plates for perfect alignment, and verify everything before proceeding. By following these steps, everyone can avoid mistakes that may compound later in the build. Right now, you are looking at the front face of the display cabinet. This project demands a phenomenal amount of dimensional accuracy. Every section's spacing must be dead accurate, because that's where the swing doors will sit later. That's why I'm double-checking every dimension, and if needed, I'll tap it into position with a rubber mallet before final tightening. And you should have noticed my usage of these flush plates, which is absolutely critical when building with aluminum extrusion. These flush plates hold both extrusions in place, flush to each other on the same plane, while I work on the joint. Without flush plates, these tasks would be harder to accomplish accurately. Now, let's close up the other side of the front face. This long extrusion needs to accept all the screw heads, and every screw must be slowly wriggled in. This took me quite a few minutes to complete. And just like the other side, we'll also need flush plates and constant measurements to ensure everything is assembled symmetrically identical. All this extra precision time is crucial. Every acrylic panel we're installing was custom cut to perfect dimensions, and any mistake here will eventually show up later. We do not want that. This is the top part of the front face. To nail this joint perfectly on the first try, I must re-emphasize the importance of flush plates. They let us complete this joint flawlessly in record time. Only when the extrusions are perfectly aligned will the drilled holes sit directly above the screw heads. We'll rely on all the precision work done so far to build the sides of the structure. Using more flush plates and the carpenter's square method, we're now installing the side extrusions. With this method, we can attach perpendicular extrusions perfectly aligned to the existing structure. I've used this approach for years, assembling countless beautiful projects with many more masterpieces to come. And after removing the flush plate, I always check for perfect alignment, and every single time it's flawless. From here, my assistant handles the rest while I inspect for errors before we proceed with paneling. We're now inserting the U-channel covers. These strips secure the clear acrylic sheets perfectly centered in the extrusions, exactly as designed. But of course, there are multiple ways to panel aluminum extrusions. You'll discover more techniques in my other videos, and I've got plenty more tricks up my sleeve. In future projects, I'll showcase even more unique paneling methods, so hit subscribe if you haven't already. Paneling options include laminated plywood, colored MDF panels, polycarbonate, acrylic sheets, laminated particle board, aluminum plates, MFT-style plywood, and coming very soon, tempered glass. Since we mentioned laminated particle board, let me demonstrate my doweling method for fitting panels to aluminum extrusion. We'll drill sufficient holes along the sides of the panel to firmly install dowels at a precise depth, with the exposed dowels fitting exactly into the extrusion slots later on. This task will need a centering tool to place holes right along the middle of the panel sides. You'll also need a drill bit that matches the dowel size, set to drill at a specifically controlled depth. And with that done, we can press all the dowels in using a spare piece of extrusion. This will set each and every dowel to the exact exposed height, which is what we need to fit into the slots perfectly. This doweling method lets us seamlessly integrate multiple panels into aluminum extrusions using the simplest of tools, with no exposed joinery and no visible techniques. Just clean, concealed results. Now that I've shown you one of my secret paneling methods, tell me what you think in the comments section. Let's revisit the 2020 drill guide system, but this time I'm drilling 5mm holes. The hole sizes are decided by the thread size of screws to be used, and in this case, M5 wood screws will be used later on. There are a few more extrusions to process this same way. With this system, I can achieve identical, accurate results every single time. We'll be adding LED lights later, requiring all cables to be hidden neatly within the extrusions. That's why we're preparing an 8mm hole now for the power cables. We have the widest range of precision drilling jigs to help us perform multiple drilling tasks. And in this instance, our 2020 Freehand Drilling Jig will precisely do that, giving us a perfect hole to work with. And with our chamfering bit, we will end up with the intended flawless result. This cabinet stands on just 2 legs, so we're adding plastic end caps to prevent floor scratches. After this, we'll move the semi-assembled structure aside to work on the remaining frame. This is the backside of the structure. We'll assemble it as one complete piece before attaching it to the main unit. Every measurement must be exact for a perfect fit. With a design this large, we'll need to clamp it securely to the workbench to keep the workpiece stabilized. By doing this, we should be able to ensure safety while we work. Since we mentioned safety, we'll also need wall mounting brackets to secure the cabinet to the concrete wall later on. And here's how we prepare the brackets in advance, completely flushed with the back of the cabinet unit. This demonstration shows even more ways flush plates improve our assembly process. If you missed it earlier, I'll show it to you again, but this time from another different angle. We're ready to merge the assembled parts together, but take note, we're only halfway through the project. The truly mind-blowing techniques will come later. For now, let's focus on perfecting the remaining parts of the frame. To secure the back frame, we'll gradually tighten all screws simultaneously. That's why I'm giving each one a partial turn in sequence, repeating until every screw is fully tightened. Once that's done, we'll need flush plates again to perfect every corner, ensuring each extrusion sits completely flush against another. To close the top, we'll use our final piece of aluminum extrusion, screws prepared at both ends, to slot into the frame while aligning precisely with all the pre-installed wooden dowels. Flush plates will be required again to get everything perfectly aligned and fully tightened down. To prevent any possible unwanted shifting of the wood panels, I'd normally take an extra step for added security by driving a couple of wood screws through the back into each panel, and that's why we pre-drilled those 5mm holes in the extrusions earlier on. By now, you should be able to tell that every drilled hole has a practical purpose, and almost all of them have to be planned and done at the beginning to facilitate a smooth assembly. Once you download the files, you'll receive all the proper drilling diagrams, and my advice is to strictly prepare all holes as the very first step. Let's now begin on the swing doors, where we will need loads of heat inserts pressed into the 3D printed parts. Using a soldering iron and an aluminum block, we can easily install these heat inserts until they sit completely flush with the surface. For these unique 3D printed parts, it took me a really long time to design every part myself, with multiple revisions, and consulted my wife twice on the overall aesthetics before finalizing this, eventually arriving at a hinge system for swing doors, perfect for 20 series aluminum extrusion. All the skills to make these parts came from years of building 3D printers from scratch, where inserts and magnets were needed in large quantities. And of course, not forgetting the painstaking journey to master the ability to first 3D model my ideas and immediately print them out. That's the luxury I've built for myself over the years, which requires a whole lot of determination. And to be honest, it wasn't easy at all. Magnets are the next thing to install. To do this systematically and avoid messing up the polarity, I'm using a steel bracket to hold all the magnets in one place before gluing them down, maintaining the same side up every time throughout the entire process. And by using an Allen key, the magnets are knocked into the sockets one by one, creating this simple mechanism that will hold the doors magnetically closed. We'll need 8 pieces in total for this part, but I'll always make 1 or 2 extras, just in case I mess up. And for the 3D printed parts that will be installed on the swing doors, I'll install the magnets this way to ensure correct polarity, with the correct sides of the magnets attracting each other. If we get the polarity wrong, it will be a disaster because the magnets will repel instead of attract. Throughout this repetitive assembly, we must really monitor the adhesive's curing time and complete each step before it sets. Otherwise, we'll have to print new replacement parts. Once everything's assembled, we'll do a test run to check it's all working properly. And as you can see here, the magnet strength is just right. Strong enough to hold the door closed, but not too strong. Therefore, we can now proceed with hardware installation, neatly storing everything away into our boxes, while also concurrently performing partial assembly of LED strip mounting components. For this project, every hardware element was intentionally designed to be discreet, enhancing aesthetics while minimizing any industrial appearance, and in this way, this product will be able to blend seamlessly into domestic spaces, while elevating the perceived value of its displayed contents. Next up, we'll bring out the acrylic panels. While we could use various materials here, they must be machinable to match our precise design templates. Given budget constraints, acrylic is our solution, though ideally, tempered glass would offer superior scratch resistance over time. But with that said, this acrylic demonstration will still fully capture the project's creative vision. For instance, combining 3D printed parts onto custom-cut acrylic, coupled with stainless steel fasteners, showcasing my material fusion concept. Right now, I'm assembling the revolving door hinge. These few small pieces alone took me a full week of trial and error to perfect. And what you see here is the final result, where every part of its design has a practical or aesthetic purpose. Furthermore, these components of the display cabinet will be completely visible to all users. Therefore, I've put every effort into making them absolutely flawless, in every possible way. Jane selected the color Fire Engine Red to match her vibrant hair, while the remaining printed parts stay black to seamlessly blend with the cabinet. Before we install the doors, there are several crucial steps we'll need to complete. A thorough turpentine wipe down will remove all stains and marks from the aluminum extrusions, restoring the cabinet's showroom-fresh black finish. Next, we'll use these hole plugs to cover all previously drilled holes, and some will need convincing to fully go in, followed by black slot covers to seal the unused extrusion slots. More slot covers will be needed later on after we complete the wiring process. Before installing the magnetic door closers, we'll need to measure carefully to make sure they're perfectly centered. When we attach the doors later on, you'll notice that they close evenly and flush against the cabinet, all thanks to these well-designed alignment parts. To work on the wiring, the structure must be flipped over. Prior to this, I had Jane arrange for the electrician to route power above the cabinet. We'll use these enlarged holes to run the wires vertically from top to bottom, very, very carefully. One slot cover will contain all wires in place, which then exit through the 8mm drilled hole at the top of the unit. During this process, we need to ensure all holes are sufficiently large to prevent cable damage when threading wires through. And at the bottom of the display cabinet, I've discreetly mounted a 12-volt power supply close to the wall, completely out of sight. My wire crimping skill comes from years of building 3D printers from scratch, because I'd always rather build something myself than buy it pre-made, whenever that option is available. I'm also surrounded by a team of electricians who regularly review my work. Think of them as my professional safety net. Over here, we'll prepare the wires for live testing very shortly to double confirm that everything is both safe and fully functional. To hold the LED strip, these 3D printed parts will hold the light at a precise angle, directing optimized luminance perfectly onto Jane's displays. Printed in black and split into parts due to printer size limits, these LED holders become fully camouflaged once assembled, exactly just as planned during the design phase. Now, let's provide power to the LED lights. The 2040 aluminum extrusion provides a completely clear channel, free from screws or fasteners, letting us seamlessly route wires from the cabinet's base to the top chamber. All my years of providing light to aluminum extrusion structures shaped the foundation of this cabinet's design. Anticipating eventual LED degradation, I've also prioritized the ease of future maintenance, because Jane will only call me for that, and no one else. Therefore, these shrink tube connectors were chosen, making future replacements easier. On top of that, I chose clip-on LED connectors instead, to eliminate soldering entirely, requiring a custom 3D printed holder for seamless integration. We'll use superglue to permanently mount the clips to their holders. When replacements are needed, only these small components require swapping, keeping maintenance really simple. And now, the LED strips can finally be installed. The length is determined now by cutting at the appropriate interval, and by using the back adhesive tape, we can roll the entire strip into position. This is just one of the many unique and unconventional techniques I've developed over the years. Throughout this whole video, I've done my best to share these hard-earned skills with you. And if you found it valuable, drop me a comment. I genuinely want to hear your thoughts. Slot covers conceal all wiring within the aluminum slot channels. The cabinet's 4 chambers split their routing symmetrically, 2 through the left extrusion, 2 through the right. When it comes to aesthetics, cable management is everything. The way we plan this web of cables decides how elegant the final product looks. And now that the electricals are hooked up, let's test it. Alright, everything went perfect. Let me clear up the mess and properly sum up the connections. All wires need to be shortened, neatly tucked into the extrusion slots, covered with slot covers, and firmly screwed into the power supply terminals. The wires will come from both sides of the cabinet. These must be neatly hidden, and exit the channels nearest the power supply for connection. And once we finish all these, the electricals are done. The swing doors will be the toughest part, reserved for the last. The door mechanism was the toughest design challenge. It combines multiple stainless steel hardware components with carefully designed 3D printed parts, plus custom-cut acrylic panels that have to fit within a precise 1 mm gap all around. Furthermore, we had to keep the mechanism absolutely minimal, preserving as much unobstructed view into the display as possible. We need that much of precision, that if the aluminum frame isn't done right, this door won't fit. But of course, I've made sure of it since the beginning, measured everything twice, and this is perfect. Each door corner must be hand-mounted with 2 screws by carefully sliding the ball spring T-nuts down the slots to align with the holes. This process needs our full attention because the swing door's movement relies completely on these joints. And of course, when done right, the door will close perfectly, with a consistent 1 mm gap all around. The other corners of the door will be fitted with the magnetic parts that we made earlier, secured with just 1 screw and a stainless steel spherical knob on the opposite end. These knobs will be the handles for pulling the door open, placed directly over the magnets. And now, with one side assembled, let's test it. The magnets worked just fine. The other side will be done the same way, also with a spherical knob. Once the trial run is successful, my assistant and I will proceed to install every door panel using the same method. There are 2 more items that I've built for Jane. I made her a counter cabinet as well as a super impressive makeup table. Everything I made for her was fully customized to her specifications, organized to her preferences, and detailed to the millimeter. And for the display cabinet we're building now, we held multiple discussions to decide on the size and height of the chambers so that all her figurines would fit perfectly within. The complexity of these projects should not be underestimated. We have created wonders with aluminum extrusion, and I always make sure to share my painstaking build process with the whole world. Therefore, if you know someone who needs a similar cabinet, please share the video with them. This is a closer look at the swing door hinge system in action. The amount of hardware was kept to a necessary minimum, providing as much unobstructed view of the displays as possible. And every single component has its own practical functional purpose, working in tandem for a perfect swing door. I'll need to flip the structure over to assemble the other side. Because I have such a sturdy workbench, I can do this safely by myself. To further explain, these are the internal components that make up the swing mechanism, as well as hold the acrylic panel in place. And once all the parts of the door are assembled, the entire setup should fit perfectly in the aluminum frame, with absolutely zero play. This is the amount of precision needed to build this display cabinet, and we will have to perform this for every door. Let's recap our build so far. This display cabinet is a unique piece of functional art. A fusion of multiple materials was used to create a true domestic centerpiece. Throughout the design, every decision was intentional. Every aluminum extrusion profile was carefully chosen, incorporating masterful internal joinery methods. You can see this in the complete concealment of wiring for a pure aesthetic, the seamless integration of 3D printed components, the intelligent use of magnetic elements, and the innovative method for lighting an aluminum frame. The result is a harmonious blend of industrial strength and domestic warmth, where all the techniques and methods become no longer important, allowing the display cabinet itself to take center stage in Jane's home. And finally, the last piece of hardware is our logo plate, the most important piece of all, before we set the cabinet aside for delivery day. The three of us transported the cabinet to Jane's home. The electrician had already left the power cables in the corner for me, so all I needed to do was make the final connection and test the lights. We flushed the cabinet to the wall, drilled into the concrete, and permanently secured it using the wall mounting brackets we had prepared earlier. With the home still unoccupied, we could work with a peace of mind, knowing we wouldn't be disturbing anyone. But honestly, there were only 4 anchor points to install, so it didn't take us more than 10 minutes to complete. And once that's done, the doors were inspected again, just in case any alignment had gone off during installation. With that, this project is complete. If I hadn't shown you the entire build process, no one would know how complex it truly was, because most of it is concealed. Jane was super excited to receive this. All her characters finally have a new home, fully custom-made, just for her. It may take her a while to fully organize her displays, but in this moment, we could already see how happy she was from the giant smile on her face. If this also put a smile on your face, go ahead and smash that like button. It lets me know I made your day too. And make sure to click on this next video, where I'll bring you along on another aluminum extrusion journey. I'll meet you there, in my workshop.